In this video, I'm looking at the 3 questions that were in my students' January mock if they did A-level maths, but not in the A-level further maths paper. So there's 3 questions, which I'm going to go through in this paper. And for the other 11 or so questions, you need to check out my other videos on pure and statistics from January 2023. Okay, so the questions that I'm going to be going through are question number 3. And then questions 8 and 9 a bit later. So question number 3, solve the inequality 3x squared minus 19x minus 14 is less than 0. Well, the first thing I'm noticing is that this is a positive parabola, so it's going to look like that. And I'm looking for values that are less than 0. So I'm looking for when that curve is below the x-axis, strictly below because it doesn't include 0. So therefore I'm looking for that range of values of x. So I essentially just need to find the roots of this quadratic is equal to 0. So what I'm going to do is on my calculator, I'm going to go into equation solver, which is here, but is also available on the smaller calculators too. It's a polynomial, okay, because it's quadratic. It's degree 2 because it's quadratic, and the coefficients were 3 minus 19 minus 14. So I'm going to do 3 minus 19 minus 14, and I get 7 and minus 2/3. So my roots then are minus 2/3 and 7. And if you like, on the sketch, this point here would be minus 2/3, and this point here would be 7. And I want in between the roots, not including the roots, because of what I said earlier. So therefore the answer is minus 2/3 is strictly less than x, is strictly less than 7. And that's the answer. Okay, the next question is question number 8. So I'm going to differentiate the cosine of x with respect to x from first principle. So we know the answer is minus sine, because we know that cos differentiates to minus sine, but the question is asked us to do it from first principles. So the answer book, flip over to question 8. I'm going to differentiate cos of x. So the first principles formula says that dy by dx, or f dashed of x if you like, is equal to the limit as h tends to 0 of f of x plus h minus f of x all divided by h. So essentially the content of that limit bracket is the gradient of the chord, and then as we take h to 0, the gradient of the chord will map onto the gradient of the tangent in the limit. Okay, so in this case, our f of x is cosine of x. So we want to say d by dx of cosine of x. That is going to be equal to the limit as h tends to 0 of cos of x plus h minus cos of x all divided by h. So all I've done there is I've just plugged in my f of x definition into this formula, which is given in the front of the book to give me this. Okay, now we can use a compound angle formula here to separate that out. So limit as h tends to 0. So cos of x plus h is the same as cos x cos h minus sin x sin h. So I'm going to get cos x cos h minus sin x sin h, and that's going to be then minus cosine of x, and that's still all divided by h. Okay. Now h is small. In fact, we're going to take h to 0 ultimately, so h is infinitesimally small. So that tells us that cosine of h is roughly equal to 1 minus a half h squared. That's the small angle approximation for the cosine function. And sine of h is roughly equal to h. Again, that's a small angle approximation for the sine function. Okay, so we're going to plug those two into the definition above. So therefore, my differential d by dx of the cosine of x, that is now going to be equal to the limit as h tends to 0 of cosine of cosine of x times the cosine of h, but cosine of h is 1 minus half h squared, minus sine of x times sine of h, but sine of h is h, minus cosine of x. And that is all divided by h. Now we can do some simplification. So the cosine of x times 1 cancels with the cosine of x over here. So I can multiply that out of the brackets and get rid of that. And then everything on the top will contain a h. So I get minus a half h squared times the cosine of x minus the sine of x times h, all divided by h. And then I can cancel the h's top and bottom because everything now contains a h in the top. So it's minus a half h times the cosine of x minus sine of x. And now as I take h to 0, then that will, well, this will disappear. So I'm left with minus sine of x. So the differential of cos of x is minus sine of x from first principles. And finally, question number 9, which is the next one, is a binomial expansion question. Okay, a year 13 binomial expansion question because the power is not a positive integer. Okay, so part A, expand the square root of 1 plus 2x in ascending powers of x up to and including the term in x cubed. Okay, so we are going to use the fact that 1 plus, I'm going to write it as a capital X to the n, expands to 1 plus nx plus n times n minus 1 on 2x squared plus n times n minus 1 times n minus 2 x cubed on 3 factorial, which is 6. Okay. So that's the binomial expansion for general n up to the x cubed term. And I've written a capital X, not a lowercase x here, because in our question, actually, we're going to be replacing that with 2x. Okay, so I just wanted to make it clear that this x here is not the same as the x written in the question. Okay, so this is just the formula I'm using. So I plug then the square root of 1 plus 2x. Every time we see an n in this formula, we're going to replace it with a half, because that's what the square root is. And every time we see a capital X, I'm going to replace it with 2x, because that's what our x is in this case. So the first term is always a 1, which is good, because we've got a 1 here, so we have to faff around with anything algebraic first, which is good. Plus nx, so that's going to be plus n, which is a half, times x, which is 2x. Actually, they'll end up cancelling. Then we end up with a half times n minus 1 is minus a half, times x squared, which is 2x squared, all divided by 2. And then the next term is n, which is a half, times n minus 1, which is minus a half, times n minus 2, which is minus 3 halves, times x cubed, but x is 2x. And that's all divided by 6. Okay, now we can just simplify the terms. Therefore, the binomial expansion up to the cubic term of 1 plus 2x, all square rooted, is 1 plus x. It's now going to be a minus term because we've got a positive, negative, positive, positive. The 2 halves are going to cancel with the 2 squared. So I'm just left with x squared on top and 2 on the bottom. So that is a half x squared. And then here I've got positive, negative, negative, positive, positive. So this going to be a positive term. Again, the halves on the bottom are all going to cancel with the 2's from here. So I'm just left with the the positive 3x cubed on top and the 6 on the bottom. And 3 divided by 6 is a half again. So a half x cubed. And that's the answer. That is only valid for the modulus of 2x is being less than 1, or if you like, the modulus of x is less than a half. In other words, it's only valid between x values of minus a half and positive a half. Okay. Outside of that range, this expansion will diverge away from the true curve. Okay, that's part A. Part B, hence expand this thing up to ascending powers of x, including x cubed. So I'm noticing here that this is the same as what I just did in part A, so the numerator is the same, but I've now got another denominator term, so I'm going to binomially expand this one up to the cubic term, and then I'm going to times them together. Okay, so for part B, I'm going to say 1 plus 9x squared to the minus 1. So in this case, using the formula above, n is minus 1 and capital X is 9x squared. I've still got a 1 here, so the expansion formula here is still valid. I can still use it. 1 plus nx, so n is minus 1, times x, which is 9x squared. And because the capital X is an x squared in this case, then the next quadratic term would actually be quartic. I don't want quartic, so I'm actually just going to stop there. So that is roughly equal to 1 minus 9x squared, and that's the expansion of that. Okay, that is the cubic expansion of that, even though it's quadratic. And now I can say that this fraction in the question, 1 plus 2x all rooted divided by 1 plus 9x squared, well, that is going to be the product of these two. So it's 1 plus x minus a half x squared plus a half x cubed, and that is times 1 minus 9x squared. All right, so to get the constant term, it's just the 1 times the 1, so that's a 1. The linear term, it's got to be the 1 times the x, so plus x. Now the quadratic term, I could do the 1 times the minus 9x squared, but I can also do the 1 times the minus a half. So I need to do both of those. Just got to pop them in the calculator just to make sure I don't make any silly sign mistakes. So 1 times minus 9 is minus 9, and then minus a half times 1 is minus a half. So that is minus 9.5, which is minus 19 halves. I could have definitely done that in my head, but hey, minus 9 halves x squared. And then the cubic term, well, that's going to come from the cubic times the constant and the quadratic times the linear. So in this case, I'm going to get minus 9 again, but this time plus a half, rather than minus a half. So that is minus 8.5, which is minus 17 halves x cubed. And this expansion is valid for the modulus of 9x squared as being less than 1, which is the same as the modulus of x squared as being less than a ninth, which is the modulus of x is less than a third. Okay. Spoilers for part C. Determine the range of values of x for which the expansion in part B is valid. Well, we want the one that's more restrictive, because for this expansion to be valid, both of these have to be valid. This one is only valid between minus a half and a half, and this one is only valid between minus a third and a third, so therefore the more restrictive is this one. So it's only valid for x modulus is less than a third, or if you like, minus a third is strictly less than x is strictly less than a third. Because you want the more restrictive restriction, because both have to be true. This one's only true between minus a half and a half. This one's true only between minus a third and a third. So only both true between minus a third and a third. Okay. Right, so those are the 3 questions that weren't in the other paper. For all the other questions in this paper, you need to check out my other video. I do explain question numbers as I go through that one. And if you have any questions, then please come and ask me or come and ask your teacher.